All right, multiplying decimals. So I'm going to show you the y first and then show you the shortcut. And before we even start with the decimals, let's multiply some large whole numbers. So you remember before when we multiplied numbers that ended with 0, you multiply the non-zero digits. 2 times 3 is 6. And then you add 1, 2, 3 zeros at the end. So that's the large number shortcut. So 2,000 times 700, we multiply 2 times 7, which is 14. And then we add 1, 2, 3, 4, 5 zeros. All right, now let's do some decimal examples. So if we want to multiply 2 100ths by 3 1,000ths, we could write this as a fraction. And normally you would reduce first, but here we'll just multiply the numerators. 2 times 3, which is 6. And that's 1 times 1, which is 1. And then 1, 2, 3, 4, 5 zeros. And then to write this as a decimal, you recall from the last section, you write the 6. You count 1, 2, 3, 4, 5. So we start at the right, we move the decimal point 1, 2, 3, 4, 5 times and fill in those empty scoops with zeros. So we moved it 5 times because there's 5 zeros in the denominator. Where did those 5 zeros come from? Well, it's from multiplying 100 by 1,000, which had 2 zeros and 3 zeros. Let's do another example. All right, so let's multiply 0.007, which is 7 over 1,000, by 0.0005, which is 5 over 10,000. So we multiply 7 times 5, which is 35. 1 times 1 is 1, and then we just add 1, 2, 3, 4, 5, 6, 7 zeros. And then to write this as a decimal, you write the 35. Start at the right, we move the decimal point 1, 2, 3, 4, 5, 6, 7 spaces and fill in those empty scoops. So let's review. When we multiplied this one, we had 2 spaces behind the decimal point times something with 3 spaces behind the decimal point, and we ended up moving 5. 2 plus 3 makes 5. Here we multiplied something with 1, 2, 3 spaces behind the decimal point, multiplied it by something with 1, 2, 3, 4 places behind the decimal point, and we ended up moving 3 plus 4, or 7 spaces. So let's see if we can do another example. So if we multiply 0.008 by 0.009, this one has 1, 2, 3 digits behind the decimal point, and this one has 1, 2, 3 digits behind the decimal point. So we're going to multiply the whole number parts. 8 times 9 makes 72. And how many places will we move it? We're going to move it, what do you think? That's right, 6 places, because there's a total of 6 digits behind the decimal point. 1, 2, 3, 4, 5, 6. So let's write that down. So the shortcut is you multiply the whole number of parts, you count the total number of digits behind the decimal point, and then you take your product, starting at the right, you're going to move the decimal point to the left that many places. Let's do a couple of examples. All right, let's try these 3 first. And if you want, you can hit the pause button, try them on your own, and then just check it with me. All right, so we have 6 times 7, which is 42. And you count 1, 2, 3, 4, 5 digits behind the decimal point. So we start at the right and we move left. 1, 2, 3, 4, 5 places. Remember, if there's nothing in front of your decimal point, you can put a 0 as a placeholder. Here we get 9 times 5, which is 45. Count 1, 2, 3, 4 digits behind the decimal point. So we start at the right and move left. 1, 2, 3, 4 places. All right, you might be thinking, what do I do with that whole number there? Well, let's review. Remember, this is either 2 1/10 or 21 over 10. So you're basically going to multiply 21 times 3, which is 63. And then how many places do we move back? Well, there's 1, 2, 3 spaces behind the decimal point. So we start at the right and go to left. 1, 2, 3 places. Let's do some more. All right, let's talk about equivalent decimals before we do the next example. So remember, you can always add zeros at the end of a decimal, and it means the same thing. So this is 7 over 100. This one is 70 over 1,000. If you reduce, you can see those are the same fraction or fractional decimal. Another thing to note is that in all of these, the 7 is in the hundredths place. That's how you can remember that all of these are equivalent decimals. So you can add zeros at the end of a decimal without changing it. You can also take away these zeros at the end. So we're going to call these extraneous zeros. So the zeros at the end after the non-zero digit are extraneous. The zero in front of the non-zero digit is not extraneous. You have to keep that one. All right, so to make your life simpler, you'll want to remove any extraneous zeros before multiplying. So in this example, which zeros are extraneous? Can I take this one away? You're right, you cannot take this one. Can I take these three away? Yes. Can I take these two zeros away? No. What about these three? Yes. And it doesn't hurt to just rewrite the problem without them so that you don't forget. So once you take away the extraneous zeros, they don't come back. It's like reducing a fraction. All right, so 9 times 7 is 63. And you're going to move the decimal point 1, 2, 3, 4, 5 places. So we start at the right and go left. 1, 2, 3, 4, 5. Let's do another example. All right, so 2.50000 times 0.0300. So you get time to hit the pause button and try this one on your own. All right, so let's remove the extraneous zeros. These zeros at the end are extraneous. This one's in front of a digit, so we keep that one. These two at the end go away. And if you like, you can rewrite the problem without them so you're not distracted. And then we multiply 25 times 3, which is 75. Count the total digits behind the decimal point. 1, 2, 3. Start at the right and go left. 1, 2, 3 spaces. Fill in the empty scoops. And there you have it. All right, now you know how to do all kinds of fun word problems. For example, if you bought 2.5 pounds of cheese that cost $4.50 per pound, what is the total cost? So you recognize that this is a rate problem because we have dollars per pound. Dollars per pound. Let's write the rate equation times the number of pounds is equal to the total number of dollars. Well, we know that dollars per pound, and we know the number of pounds. So we're looking for the total number of dollars. Get rid of extraneous zeros. We have a missing product, so we want to multiply 45 by 25. 5 times 5 is 25. 5 times 4 is 20, plus 2 is 2. Add a 0. 2 times 5 is 10. 2 times 4 is 8, plus 1 is 9. $1,125 sounds like a lot of money for cheese. Oh, but we have 1, 2 digits behind the decimal point. So we start at the right and move to the left. 2 places. So our total cost is $11.25.